Okay. So good afternoon again. So we will start module 1. In module 1 we have basically thermodynamics of chemical reaction, although the module is not having a such name, but just this is the topic. Introduction to solid, liquid and gaseous fuels, that is different types of fuels that we can use, okay, for our purpose. What is fuel we will discuss. Then stoichiometry, this is the mass conservation, right? Mass balanced equation we will study. Then you have exhaust gas analysis. Exhaust gas analysis means basically you have in the reaction you will see that there are two kinds of things. One is called the reactants, okay, which is going to react, and after the reactants this is called products. So exhaust gas basically is the product which is actually the name, that is exhaust gas is the name for the products of the chemical reaction, that is combustion. Combustion is a particular kind of chemical reaction, that is basically exothermic reaction. Okay. Now exothermic reaction means basically what will happen, there will be some release of energy, thermal energy, right? From chemical energy it will be converted to thermal energy. So that is a particular kind of reaction, exothermic reaction. So exothermic means energy will be released in the form of thermal energy. Chemical energy will be converted to thermal energy. Chemical energy means energy within the fuel. Energy is there in the fuel. So that is one form of internal energy, and it will be converted to another form of internal energy of the product of combustion. So in the reactants there will be some form of chemical, some form of internal energy. All are internal energy, right? Chemical energy or thermal energy, both are basically internal energy. So in one form, in the reactants it will be in the form of chemical energy, that means within the chemical bond. So that will be the energy related to bond. Okay, not recording? Okay. So that is energy related to bond. Okay. So in the atom or molecules, for example, so there will be chemical energy that is related to the bond energy, electronic bond. Now when that bond will be broken and some new bonds will be created, that is a chemical reaction, and after the chemical reaction some chemical energy will be converted to thermal energy and it will be released, so that temperature will rise. Okay. So that is exothermic reaction. Okay. So exhaust gas analysis means basically we will have some exhaust gas, we will analyze that and we will try to predict the fuel. That means, say for example, we do not know what is the fuel, we analyze the exhaust gas and from that we try to predict what was the fuel, what is the chemical formula of the fuel. So that is the thing. Okay. From that is again using stoichiometry. Okay. So that is actually a back calculation. So from the stoichiometry you can have some fuel and air and you can calculate what is the product of combustion, what will be the product of combustion. So this is forward calculation. And exhaust gas analysis means you know the products, right? So on the left hand side you have reactants and on the right hand side you have products. So from the products, from the known products, that is exhaust gas, you can analyze and calculate what is the reactants. That means individually exhaust gas components you know, say for example CO2, CO, then H2O, oxygen, nitrogen, etc. All the components individually you know, then you go for balancing and from that you guess what is the reactants, that is what is the fuel. Clear? So that is exhaust gas analysis. Then we will, so that is, so far we are discussing mass conservation, right? So that means stoichiometry, exhaust gas analysis, these are all mass conservation. Next we are coming to energy conservation, first law analysis of combustion reaction. So now is energy conservation. Energy conservation, first is mass conservation, mass balance, then we are discussing energy conservation. So first law analysis of combustion reaction. Okay. In the first law there will be certain terms, okay, like say enthalpy of combustion, etc. So as in case of your say for example phase change, the chemical formula was not changed, right? Say H2O from liquid to vapor it was converted, but that was having same H2O but it is in different form, physical form, right? So there was no chemical reaction, but the energy that was involved was latent heat, right? That is called heat of boiling or heat of evaporation. or enthalpy of evaporation, enthalpy of say vaporization, etc. Next we have basically chemical reaction. So that is another type of reaction, another type of change of material. So from one chemical to another chemical, or from a set of chemical to another set of chemical. So there is basically energy involved in a different aspect, right. So in case of phase change, you have basically only, so you see that molecules will be, molecular bonds will be broken, right. So difference H2O, in ice it is in a particular form, right, structural form. Then you water, you different form between the molecules of H2O, and in gas you have a lighter bond, right. So it's a molecular bond, but in case of chemical reaction, you have different thing, means the atoms will be the atoms of different molecules will be broken and created, or the bond of atoms of the different elements will be broken and created. So that is basically electronic level, at the electronic level. It is not in the molecular level, it is in the electronic level, right. So there will be different electron exchange, etc. will take place depending on whether it is a covalent bond or means ionic bond, right, like that. So most of the time in our combustion it will be basically covalent bond, right. So the matter is that there will be kind of energy conservation, first law, and the energy involved will be basically heat of combustion or heat of reaction or enthalpy of reaction. So there will be a kind of change which is basically a chemical change, and corresponding energy that is there, it is called basically enthalpy of combustion or heat of combustion or heat of reaction, right. So that we will see during the discussion of the energy conservation, right. Next topic is basically that heat calculation using enthalpy tables. So there will be, as you have steam table, so phase change, for a phase change you have steam table, right. Say for example either from solid to liquid, right, or from liquid to vapor, or vice versa. Then you have basically enthalpy tables, that is called steam table. They are simply for steam, H2O. But in case of chemical reaction, you have different things. What you see that hydrocarbon and oxygen will be reacting and producing product of combustion. So you can have different hydrocarbons. Say for example for H2O, you have only H2O, right. Say for example in the boiler you have only H2O. So you are heating H2O, water or liquid will be converted to vapor, right. So simply in the steam table you will see that there is only H2O, right, at different phases depending on temperature and pressure, right. That is called saturation temperature, right. So depending on temperature and pressure, you have definitely you have basically the only H2O in the table, you will not see anything else. But in the enthalpy tables that you will see combustion is a different thing, because you have reactants means what? You have say oxygen or oxidizer and hydrocarbon or fuel. You see these two can be different, right. Say generally oxidizer means we consider air, and in air basically oxygen. But in chemistry you can have oxidizer means a general oxidizer, right, which can oxidize, right, and the fuel will be basically oxidized. So fuel means basically hydrocarbon, but it may be always not hydrocarbon, it may be alcohol also, right. So it is not only hydrogen and carbon, it can have oxygen also, right. So therefore this is completely general one, therefore you cannot have a particular table, right, for methane or for ethane or ethyl alcohol, methyl alcohol. You will have tables for different hydrocarbons, okay. But there will be a general one also, which is basically involving a chemical bond between hydrogen and carbon, okay. So for example in methane, how many hydrogen and carbon bonds will be there? 4. In ethane there will be some more, right, but there will be carbon and hydrogen bond in general. So depending on how many numbers are there, that is a different thing, but generally there will be hydrogen and carbon bond. So in the table you will see that there will be a carbon hydrogen bond, and what is the enthalpy of that, right, that or the bond breaking energy, okay, bond dissociation energy, that we will see. One thing which is general. Again you will see there is a carbon and carbon bond, carbon single bond, carbon double bond, carbon triple bond, and accordingly what is the amount of bond dissociation energy for that, we will see enthalpy tables, that in general called enthalpy tables. And also for a particular reaction what will be the enthalpy involved, that we will see during the discussion of heat calculation using enthalpy tables. Okay, that is a completely different table than steam table. Okay. Adiabatic flame temperature we will see for during the combustion, a particular parameter that is called adiabatic flame temperature. Chemical equilibrium and equilibrium composition means chemical reaction always does not take place from complete reactants to complete product. So, if we assume that all the reactants will be completely converted to the products, it is not the case. Okay. There will be always some composition of reactants and products, that is called a composition called chemical equilibrium composition. That means depending on the temperature, pressure and the amount of reactants and products, there will be a particular point where the reactants and products will be having a balance. So, the further chemical reaction towards increasing the products or towards switching towards the reactants will be only possible by tuning the parameters. That is called equilibrium condition, and that equilibrium condition will be governed by second law. So, you see that we are coming from what? Mass conservation, stoichiometry, exhaust gas analysis, then we have energy conservation, that is first law, right? Energy conservation, what is the energy balance for a particular reaction. Then we are going towards a condition which is governed by second law. That is, now second law means basically in your so far what we have seen, that balance of entropy, right? But in chemical reaction we will see that balance of entropy, more than that balance of Gibbs free energy is more, that is called general one. Okay, balance of the Gibbs free energy. Okay, change of Gibbs free energy will be 0, that we will see, that at the equilibrium condition change of Gibbs free energy will be 0. So, that is called the equilibrium condition or equilibrium criteria. Okay, so you can understand these steps, right. So, first we will discuss the chemical reaction, that is what is the component of chemical reaction, that is fuel, and then oxidizer is there, okay, oxygen or air. After that the chemical reaction, mass balance, energy balance and entropy balance and Gibbs free energy, that is criteria. Clear? That is the brief. Okay, clear? Is it clear? Next we will go towards the objectives. So, these are the objectives that we have already discussed briefly now, right. Air fuel ratio will be important, definitely one important parameter, that is air fuel ratio. This conservation of mass I have discussed. Then in the stoichiometry, air fuel ratio will be important during combustion. Combustion is a particular kind of chemical reaction. Next we apply energy balance, that we have just mentioned. Then calculate the enthalpy of reaction for a particular reaction. What is the enthalpy of reaction? You will see that there will be three things. One is enthalpy of reaction, then enthalpy of combustion, and enthalpy of another thing is enthalpy of combustion. Mainly two things. So, combustion is a particular kind of enthalpy of reaction, okay, or heat of reaction, whatever. Another thing that we will see also, that is called calorific value. Okay. So, then determine the adiabatic flame temperature is a particular kind of condition which actually gives you adiabatic flame temperature. Then entropy change reacting system, okay, and then analyze the second law, that is Gibbs free energy and the equilibrium condition or equilibrium criteria. Next, what is fuel? Fuel, you know that it will be definitely is a particular reaction, a particular component or say compound which will burn and it will release thermal energy, right. So, it will basically release thermal energy. That means inherent inside the fuel there will be some stored energy. Inside the fuel there will be some stored energy stored inside the fuel. But that, say for example you have a chunk of coal, right. Inside the coal there is some hidden energy which I cannot see, which I cannot realize, right. But when you burn or when you subject that fuel with oxygen at a particular condition, then it will burn and release that stored energy in the form of thermal energy. But both are internal energy. This is, you see, that this is internal energy to the reactants and this is the internal energy to the products, POC, product of combustion. Clear? But both are basically internal energy, that you have to understand. One is internal energy of the reactants, another is the internal energy of the products. Is it clear? Okay. Next, what happens, whatever product of combustion expands and go towards it may be internal, it may be in the internal combustion engine, that is reciprocating engine, it may be in the gas turbine. So, the target is to use the internal energy in the form of thermal energy to do the work. Say for example, it will expand, right. In the IC engine it will expand and it will push the piston. In the gas turbine it will move through the turbine and it will expand and it will rotate the turbine in the process of expansion. Clear? So, that means thermal energy means what? It will have high temperature, high pressure. Now, that high temperature and high pressure means high enthalpy. So, from that high enthalpy it will convert that enthalpy to work and the enthalpy will be reduced and it will go to a low temperature and low pressure. So, from high temperature, high pressure it will go to a low temperature, low pressure, that will basically convert the internal energy to work. Is it clear? Is the process clear? Working? Okay. So, fuel and oxidizer, product and thermal energy. This is the means schematic. Okay. Then primary constituents are carbon and hydrogen, but it can have also oxygen, right? Now, three phases of hydrocarbon fuel: solid, liquid, gas, that we have just mentioned. Solid fuel means basically mainly coal and the constituents remain in the vegetation, right. It will be basically in the process of suppression by high temperature, high pressure, right. So, the deposit passed in the geological age and that actually happened after subjection of the biochemical action at high temperature, high pressure and submersion. So, it was basically in the layer after layer, it was in the submerged condition and it was with say crores or billions of years it was produced, that solid fuel, right. So, two kinds of analysis will be there, one is called the proximate analysis, another is called the ultimate analysis. Proximate analysis means basically you can see that it is kind of approximate analysis. Proximate means basically approximate, right. This is a gross analysis and ultimate analysis means it is exact analysis. Okay. So, this we will see on a mass basis, both are on mass basis. Mass basis means basically per unit mass of the fuel. So, percentage per unit mass of the fuel. This is called gravimetric analysis. Another is called volumetric analysis. Say for example, exhaust gas, sometimes you will see that there will be volumetric analysis or gravimetric analysis, right. So, volumetric means per unit volume and gravimetric means per unit mass. Okay. So, they will be basically used to determine the constituents of the fuel. Okay. Say for example, you have some coal, then you go for analyzing it so that you can calculate what is the constituent and then go for calculating or determining its calorific value by some arrangement, that is called Bohm calorimeter. Using that you can calculate the calorific value, but before that you have mass analysis and then you have basically energy analysis. Clear? So, this is mass analysis, proximate analysis and ultimate analysis. So, what are the constituents that you calculate? Moisture. So, the coal can contain some moisture. Then volatile matter, some volatile matter will be there, right. Volatile matter means basically which will be evaporated easily, right, at a particular temperature and pressure. And then fixed carbon and ash. Ash means basically which is non-combustible. So, already there can be some ash which is non-combustible, means which will not take part in the reaction. It will be basically inert to the reaction, solid thing, but it will be inert to the reaction, right. It will not take place, it will not take part in the reaction and it will finally remain as they are. That is called ash. Okay. Now, this is also the similar thing, but here you have basically exact analysis as received or dry basis. This will be dry basis, there will not be any moisture. So, it will be basically calculated on per unit mass without the moisture. So, on a mass basis, relative amount of carbon, sulfur, hydrogen, nitrogen, oxygen, exactly, right, exact analysis, right. Here you see only fixed carbon you analyze, but here exactly what is the constituent, what is the constituent of the fuel that you analyze, carbon, sulfur, hydrogen, nitrogen, oxygen and S, exactly. Here we do not consider the moisture, clear. So, proximate analysis and ultimate analysis in brief, right. Some important properties of coal for its uses. So, fusibility of the ash. So, ash should be actually fusible, it should be basically it should not be chunk, right. So, it should be fusible and it should be means as small as possible, right, so that it can be transported easily, right. Then grindability or ease of pulverization, because we do not use coal as a chunk. What we do basically in furnaces, we basically go for pulverizing the coal. Pulverization, what it increases? It increases the surface area, and we know that combustion is a surface phenomena, right. So, combustion takes place from the surface. So, if you keep the coal as a chunk, then it may be possible that internally it will not take part in the combustion. So, it will remain as unburned and it will be a loss, right, and the efficiency of combustion will be less, right. So, you expected from that amount of coal, say for example 1 kg of coal, you expected some amount of thermal energy, but because of the inefficiency of the combustion, all the coal will not take part in the combustion, and therefore some will be remaining unburned. So, grindability or ease of pulverization is very important, right. It should be easily grindable, pulverizable, right. So, that is called actually fluidization of the coal. So, it is like you cannot make coal fluid, right, because it will not burn. Say for example, if you mix it with say water, it will not burn, but if you can make it pulverized and you can make it powder and you can float it, right, from the suspension, from some arrangement from the air will suspend it and it will be taking part in the combustion, right, that is called fluidization, okay. And weathering characteristics and size. So, size is also important, and means depending on the weather you must have this easily weatherable, right. So, that is the thing. Next is so some liquid and gaseous fuels. So far we discussed about coals, that is solid fuel. Now liquid and gaseous fuels. So generally I have given some name of the family, then formula, general chemical formula, then structure and whether they are saturated or not, okay. So the first thing is you see paraffin, olefin, diolefin, naphthalene, aromatic, right. So this is saturated, this is saturated. So paraffin means basically formula CnH2n plus 2, right. Alkane, this is called alkanes, ANE, alkane, right. So alkanes. There is a suffix alkane, okay. So paraffin, alkane, and structure is a chain, straight chain or branched, whatever, but they are not basically kind of ring, they are chain. Then is saturated, it is saturated. Olefin means single carbon single say one double bond, okay. So alkane means carbon single bond, saturated. And alkene, olefin, alkene. So it is carbon double bond there is there, one double bond is there, called alkene. Then diolefin means basically there will be two carbon double bonds, diolefin, diolefin. So there will be two numbers of carbon double bond, two numbers, clear. And also there will be alkyne, Okay, alkyne and diolefin, they will have the same similar general structure, but here you have double bond, and alkyne there will be triple bond. So alkyne is also there, alkyne, so there will be carbon carbon triple bond, and that is also unsaturated, definitely unsaturated. Okay, so after that diolefin you can include alkyne. Okay, but the general formula will be same, general formula will be same. And naphtene is basically called cycloalkanes. This is naphtene or cycloalkane. So this one is a ring, it is saturated, but you see that the structure of this and this are same, general formula is same, but it is circular, it is actually cyclic ring structure, and it is straight or chain. It is unsaturated and it is saturated. So for example, minimum cycloalkane is basically cyclopropane, right? Say for example, you have carbon carbon carbon, this is called cyclopropane, right? So you see two bonds are engaged, so it will be H2 and H2, cyclopropane. Cycloalkane, right? And you can go for increasing cyclobutane, cyclopentane, cyclohexane, like that. Okay. Now aromatic, in this you have basically benzene and naphthalene. Benzene and naphthalene, they are also ring structure, but they are unsaturated. This is naphtene, you see, naphtene and naphthalene, these are different. Naphtene, this is cycloalkane, this is cycloalkane, this is saturated, there is no carbon carbon double bond or triple bond. But in case of aromatic, you have carbon carbon double bond in a ring structure. So this is benzene and this is called naphthalene. Okay. So there will be basically kind of naphthalene, as I recall, naphthalene will be two carbon carbon double bonds, ring structure, two double ring structure, as I can recall. Okay. So this is the general thing about the liquid and gaseous fuels. So within this you can have liquid and gas depending on the volatility, etc., or boiling temperature. Okay. Now the petroleum, from the petroleum crude oil, the hydrocarbons are produced by called fractional distillation. Okay. So there will be a tower. So in the petroleum refinery there will be tower, and here basically it will basically produce as it goes, and it will heat it depending on the volatility, depending on the boiling temperature, there will be settled in a different that means stages. Okay. So you can see that here you see that it will be released finally. So 1 to 4. Okay. Can you see that numbers? Carbon 1 to 4, then 5 to 9 or 8, then you have 8 to 10, like that. So depending on this there will be different requirements. You see that liquefied petroleum gas, that is called LPG. So finally that is the volatile one. So that is naturally available in the form of gas. That is actually liquid petroleum gas, means basically propane, mainly propane. So some blending will be there. Liquid petroleum, then you have other chemicals, naphtha, then gasoline, this is gasoline, then kerosene, paraffin oil, then diesel oil 14 to 20. These are the temperature or this boiling temperature. Okay. So these are the boiling temperatures. Then diesel oil, then lubricating oil, little you see that the viscosity is increasing, that means volatility is decreasing. So and also molecular weight is increasing, as the number of carbon is increasing, molecular weight is increasing. So lubricating oil, it is thicker lubricating oil used for, that is reducing the friction, etc., in engine components or other relatively moving components, and it's 20 to 30, like that. Okay. So then lubricating oil, then you have basically other engine, that means you will see that some ships use fuel oils. So, this is fuel oil, right. Fuel oil means basically ships use fuel oil. So, this will be very thick and it will be heated before, preheating will be done before the use. Okay. So, there will be a very thick viscous form, it will be heated before it will be used in the ships. Okay, that is called fuel oil. Okay, so it will be very thick, like just like peach. Visually you will be seeing like peach, but it will be heated before using. So, it will be liquefied by heating and then it will be used. Okay. So, this is a general idea. So, crude oil will be supplied and then accordingly it will be extracted at different stages. So, crude oil is supplied and then heated, and then this is called fractional distillation, okay, in the refinery. So, distillation column, this is called distillation column in a refinery, petroleum refinery. So, this is the book that we have referred, Sontag, right, Fundamentals of Engineering Thermodynamics, Sontag. Okay. Next we have basically the fuels, paraffin series. So, methane, ethane, propane, butane, isobutane, these are different paraffin series, that is alkane. So, methane, ethane, this is the first one, then this one. So, this is the suffix which is used for general name. Carbon, carbon single bond is there, right, this is saturated one. Then olefin and diolefin series, the next one you see that there will be a single carbon carbon double bond, right, and this is a double, means two carbon carbon double bond. So, this is called the olefin and this is called diolefin. Di means two numbers of carbon carbon double bonds are there. So, this will be the suffix in, okay, alkene, okay. So, ethene, ethene is the name, means there will be two carbon and there will be two carbon carbon double bond, sorry, one carbon carbon double bond. Then alkynes, the third one, carbon carbon triple bond, ine is the surname or suffix, and ethyne, right, acetylene, right, or propine. So, there will be three carbons, I think this is propine, yes, and this is butane, one butane. So, this is UPAC name. So, the carbon carbon double bond is at this position 1, right. But for example, in UPAC you can have basically carbon carbon triple bond here also. So, for butane there will be, it may be possible that it is one butane or two butane, right, but for propine it will be always one. So, I need not mention that. So, it will be always here or here. So, wherever you have the carbon carbon triple bond, you will start counting from that point, that carbon, okay. So, this is one butane, you can have two butane also, right. Or you can have basically for a carbon carbon triple bond you can have a branch also, right. So, that is also possible. Branching, okay, we will see that. I think here branching will be possible here only, not here. Carbon carbon triple bond already one, not branching is not possible, right. Okay, I think today we can close. We will discuss starting from this point tomorrow, okay. Thank you. Close that.